Welcome everyone. So our new topic is electric dipole in an electrostatic of the chapter electrostatic potential and capacitance. So let us see the first topic, which is the electrostatic potential due to an electric dipole. Students, we know if we are just taking two charges and they are separated by a distance like 2a, which I'll just take in over there. As you can see, the complete distance of this one is a 2a, which we will divide from the center at a half portion. So this Q is makes at a distance R1 from the point P and minus Q, which makes as a distance R2 from the point P. Again, if I'm just taking another type of a distance like a from the center. So from the center, I'm just taking the distance between the point at the center and the P is R. What we have to do in the case of a particular potential, we have to calculate the potential for each and every charges. Like if P will be the point where we have to observe the distance from the center of the dipole, which is AB. So what we are going to do from figure, it is clearly mentioned that R1 is equals to, as you can see over there, R1 is equals to what is R minus A cos theta. R minus A cos theta. So the case of R2, this will be R plus A cos theta. This will be R plus A cos theta. These two values, I'm just assuming this is equation number 1. Electric potential due to the positive charge if I'm taking. So V1 is equals to 1 by 4 pi epsilon naught plus Q divided by R1. What I'm just going to do, put this value of R1, which is the value of this R minus A cos theta over this particular equation. And the second case for the minus Q charge, if I'm just putting the value of a minus Q in the potential, like a V2 is equals to 1 by 4 pi epsilon naught minus Q divided by R2. We get the result for both the potentials, that is a V is equals to V1 plus V2. Equating all the particular points as an equation number 4. So from equation 1, where we saw the value of R1 and R2, we just put the value of these particular terms in the equation number 4. Then we get V is equals to Q divided by 4 pi epsilon naught in the bracket 1 minus A cos theta minus 1 divided by R plus A cos theta. Little bit here I'll just use the term of algebra to get the result, which is V is equals to Q by 4 pi epsilon naught. There will be, I'm taking cross multiplication, we get R plus A cos theta because of minus R minus A cos theta divided by R square minus A square cos square theta. Here, as you can see, because of a negative sign, this negative symbol converted itself as a positive, which as you can see over there. Now, as you can see, R and R, these two R will be cancelled out each other because of their sign convention. And as these two particular terms in the same sign convention, they will be added up together. We know that A, the value of A actually is less than R, and A square is neglected, and A square cos square theta is also neglected. So if I just put all these value over there, we get the value of 2A cos theta. So what is a Q into 2A? That is a P. That means the value of a potential which we will receive from here, that is a 1 by 4 pi epsilon naught P cos theta divided by R square, or electric potential or electrostatic potential at any point due to an electric dipole we receive, that is a V is equals to 1 by 4 pi epsilon naught P cos theta divided by R square. Now here there will be some situations over there. What is that situation? I just want to elaborate, then we will move on to next topic, that is this totally depends on the value of a cos theta. Like if I am just taking the axial point. So for axial point, the cos theta will be 0. So the value of a cos 0 will be 1. This will be the value of a cos 0. That time the potential will be K divided by R square. But if I'm just taking the scenario when the theta is equals to 90 for the case of a equatorial. This is a case of a equatorial and this is a case of the axial. So for the case of a equatorial, we know that the value of a cos 90, this will be 0. So for this scenario, V is equals to 0. So these are two basic particular points. According to the theta, we will just see where that actually potential have. Next, we have a electric potential and electric dipole in an electric field. So here we are taking a particular dipole. What is the meaning of a dipole over there? If two charges are placed at a particular distance, which we will take over there 2a. So there will be a electric field generated. So we just taking the electric field upside like this. So because of a torque or because of this field lines, these two charges feel some experience, some external force. Because of that force, there will be applied torque will be generated. So let dipole moment of a B and its length will be 2a. Electric dipole is placed in the uniform electric field E with the angle theta to the field of a direction. We know that tau is equals to PE sine theta. So PE sine theta is a factor actually which is generated by the tau. Tau is a what? That is an angular moment. Because of this electric field, these two charges faced that angular moment towards. So work done in rotating the dipole through an angle d theta is dw is equals to tau d theta. See, we have to do work. And we know that work is a what? Force into displacement. But here the displacement, as you can see, this will be angular. So again force, instead of a force, here this will be the term couple of a moment will be arising and the displacement which we are taking d theta. So dw is equals to, I am just putting the value of a tau over there. This will be PE sine theta d theta. Now total work done for rotate the angle 90 to theta, this will be 0 to w. dw 90 to theta, this will be PE sine theta d theta. If I just put these values and little bit solution need over there, the result will get w is equals to minus PE cos theta minus 0. And the last result is w is equals to minus PE cos theta. Here the work then is stored in the form of a potential energy, as you can see over there. So final result which we have a u is equals to minus P, which is in vector form, so minus vector P dot vector E. That means electric potential energy of an electric dipole in an electric field is u is equals to minus PE cos theta. Student, hope you understand. So what we have to note it down, which is the most main criteria, that is if theta is equals to 0. As I told you, for the axial position you can say, or for the stable position you can say over there. So theta, when the theta is equals to 0, this is a situation of a stability. So that time potential energy is equals to minus P. Okay. Next we have theta is equals to 90. So cos 90 will be 0. Potential energy will be 0 for there. Next we have theta is equals to 180. That will be comes minus 1 cos 180. So potential energy becomes positive. As we can see over there, potential energy. So if the complete rotation occurred, then the potential energy becomes positive in nature for a complete rotation or complete torque. Now, let us move some MCQ questions like a multiple choice questions so that we can understand what actually we learned, we understood or not. Electric potential energy of an electric dipole in an electric field is, we have an options are u is equals to minus PE sine theta, u is equals to PE cot theta, u is equals to minus PE tan theta, u is equals to minus PE cos theta. So what is the correct answer for that? Yes, the correct answer is U is equals to minus V cos theta. Next, we have electric potential energy in two charges of a system in an electrostatic field or external field. This will be U is equals to 1 by 4 pi epsilon naught Q1 Q2 divided by R12. U is equals to 1 by 2 pi epsilon naught Q1 Q2 divided by R12. Next, we have a U is equals to 1 by pi epsilon naught Q1 Q2 divided by R12. And the last, U is equals to 1 by 3 pi epsilon naught Q1 Q2 divided by R12. So what is the correct answer for that? The correct answer for this question is option A. So I hope you feel very energetic things and learn many things in that particular scenario and sessions. So again, revise these topics. Be ready for the upcoming examinations and the things. Wait for the next topic. Until that, take care everyone. Thank you for watching this video.